Hello, this is FASTECH. I would like to explain the test results comparing the response time between Ezi-SERVOII Plus-E using Ethernet network and Ezi-SERVO Plus-R using RS485 network. Among the product name, plus means that a motion controller has been added. E means Ethernet network and R means RS485 network. To tell the conclusion first, the response time of Ezi-SERVOII Plus-E is 10 times faster than Ezi-SERVO Plus-R. I will explain how we compare these two products. First, I will explain the conditions and terms. Response time is the time until checking the data which is received from the drive at the host controller after sending command value to drive at the host controller. I will explain how to measure a response time in this test. For example, we send servo enable command, which can set servo on-off status from PC to drive, and then check the data which is received from the drive at PC. This method is repeated 1000 times. The starting time to send servo enable command is A. The time when receiving 1000th reply at PC is B. When repeats the same command 1000 times, the average response time is like this. Therefore, the response time is that the difference between the starting time to send servo enable command and the time received 1000th reply at PC is divided by 1000. We did a test of response time as this method. And I will let you know the test environment. The test environment is like this. The response time of Ethernet network was measured under these environment, and in the case of Ezi-SERVO Plus-R, when the communication speed was 115,200 bps, it was measured by using FASTECH's FAS-RCR converter. When the communication speed was 921,600 bps, a PCI board was used. The test result can be different by test environment like PC specification, OS, etc. The writing or reading ROM of the drive is not related to communication speed, so it is excluded from the test result. Next, I will show you the test result. FASTECH provides API for Windows-based programming. The function is compatible with both FASTECH Ethernet products and RS485 products. This is the result of measuring the response speed by repeating 10 times for each command using the method described before for 38 of 60 commands. For example, in the case of FAS get actual POS, which is a command that requests the current actual position value, an average response time is 0.145 millisecond as a result of the test. This is the response time of the 5 most used commands. The red graph shows the response time of Ezi-SERVOII Plus-E. The green graph shows the response time when the communication speed of Ezi-SERVO Plus-R is 115,200 bps. And the light green graph is when the communication speed of Ezi-SERVO Plus-R is 921,600 bps. In the case of FAS get all status, a command that reads I/O status and operation status flag value, current operation progress status, and PT number in operation, the response time is 0.1621 millisecond with Ethernet network, and the response time of RS485 with 115,200 bps communication speed is 5.7425 millisecond. In the conclusion, the response time with Ethernet was about 35 times faster than RS485 network. As a result of the test, the response time of Ezi-SERVOII Plus-E is 0.156 millisecond when the average value is calculated for all functions. And when the communication speed of Ezi-SERVO Plus-R is 115,200 bps, the response time is 3.561 millisecond on average. When the speed is 921,600 bps, the response time was measured as 1.206 millisecond on average. From the test results, you can see that the response time of Ezi-SERVO Plus-E is about 10 times faster than when the communication speed of Ezi-SERVO Plus-R is set to 921,600 bps, which is the fastest. The following is a graph measuring the response time of Ezi-SERVO Plus-E and Ezi-SERVO Plus-R for various commands. As you can see, Plus-R has a large difference in response time depending on the command, while Plus-E has a constant response time. When sending different commands to multi-axis at the same time, Plus-R has the case that setting delay, as much as a difference of response time for each command, before executing the next command. But, Plus-E is not needed to set delay, because of response without a difference. For all commands, you can see that the red graph of Ezi-SERVO Plus-E has the shortest response time. In addition, if the command needs to be executed continuously, the response time of Plus-E is fast, so it can perform the continuous command quickly, whereas the response time of Plus-R is relatively slow, so it is needed to wait as much as response time to execute the next command. Take the get-all-status command as an example. In the case of Plus-R, the response time of the command is 5.74 millisecond, and you have to wait at least 6 milliseconds to execute the next command. On the other hand, in the case of Plus-E, the response time of the same command is 0.16 millisecond, so the next command can be executed almost immediately. The reduction of the execution time according to this response time affects the takt time, and the takt time can be shortened when using Plus-E. In the Ezi-SERVO Plus-E drive, there is an embedded 2-port switching hub. Due to this 2-port switching hub, we can connect up to 254 axes by daisy chain. In this part, I'll show you how to measure the delay of the switching hub. When Ezi-SERVO Plus-E is connected in a daisy chain method as follows. We measured the delay of the switching hub built into the drive. If the response time when sending the FASTECH enable command to the first drive is A, and the response time when the same command is sent to the nth drive is B, the delay of one switching hub, that is, the switching hub for one drive, can be calculated as follows. For example, when 5 Ethernet drives are connected, the delay per switching hub is 0.013 millisecond. And when 11 drives are connected, the delay per drive is 0.0133 millisecond. As shown in the previous measurement result, the response time of the getActualPOS command of Plus-E was 0.145 millisecond. And the delay of one switching hub is 0.013 millisecond when 5 axes are connected. Now, if you calculate total response time, the response time of the 5 axis when the getActualPOS command is transmitted to the 5th drive as 0.197 millisecond through this equation. And the total response time when the same command is sent to all 5 axes is calculated as 0.777 millisecond. In other words, even if a command is transmitted to all 5 axes, it is 0.777 millisecond, and it takes less than 1 millisecond. I will show you a demonstration using Ethernet network. This 32-axis ball demonstration consists of 28 axes of Ezi-SERVO, 4 axes of Ezi-SERVO, which is attached Ezi Motion Link, which is FASTECH's Ethernet-based 1-axis motion controller, and Ethernet Digital I/O module. Ezi-SERVO and Ezi-SERVO are controlled by using FASTECH API with one Ethernet network. The products used in this demonstration are as follows. By applying Ezi Motion Link to Ezi-SERVO, such as Mitsubishi, Panasonic, Yaskawa, and Sanyo, a total 32 axes including Ezi-SERVO Plus-E and Ezi-SERVO were controlled at the same time. As you can see, AC-Servo and Ezi-SERVO are controlled by one network and program. There is no need for a separate motion board and can be operated simply with a PC. FASTECH has 7 types of Ethernet products. There are 3 types of closed-loop stepping system, 2 types of open-loop micro-stepping system, and 1 axis motion controller. Digital I/O module. Ethernet response time is 10 times faster than RS-485, when the communication speed of RS-485 is the fastest. So, Plus-E can connect more axis by daisy chain than RS-485. Ezi-SERVO Plus-R can connect up to 16 axis, but Ezi-SERVO II Plus-E can connect up to 254 axis by daisy chain. FASTECH offers Windows API. By using that, customers can programming with C++, C, C#, Visual Basic, LabVIEW. Plus-E, that is, it has embedded motion controller, does not require a motion board. By using a standard Ethernet network, you can control various FASTECH Ethernet products and AC-Servo at once with a fast response time. On the FASTECH website www.fastech-motions.com, you can download product-related materials such as catalogs, manuals, drawings, and watch demonstration videos and webinars. Also, if you search FASTECH on YouTube, you can see more than 100 demonstration and webinar videos. Thank you for listening.